Alright, Merry Christmas, everybody. Now, today I'm back to this channel and try to update my ACE data scientist interview probability questions. Last time I only did part 1, which contains the first 5 questions of that session. Today I am going to continue to the 6 to 10 questions in the easy level of the probability questions in a data scientist interview. So now let's get started. I'm back on sharing the second part of this probability questions. So let's start from number 6. I forgot to tell you, today I decide to bring my own GVM. I hope you like it. I just really need it. All right, so the first question, 1 in 1,000 people have a particular disease and the test for the disease is 98 correct in testing for the disease. One, on the other hand, the test has a 1% error rate if the person being tested does not have the disease. If someone tests positive, what are the odds they have the disease? All right, take your time and try to solve this problem, and then I will review the solution. Good luck. Okie dokie. I realized the BGM doesn't really work when I'm sharing my only screen, so just forget about it. You can open your own BGM if you want. Um, I'm just gonna use and enjoy my BGM by myself. Okay, let's start on this question. To actually solve this question, you should be familiar with a concept that's a concept called the Bayesian theorem. You guys probably already know the theorem anyway, but if you don't like pretty much review it, you will forget it. So let's review this concept first. Okay, so here this is the basic idea of the Bayesian theorem, and this part means so the probability A occurring given that event B has occurred, and this one would be condition probability of B when given A is happened, and this is probability of A and probability of B. Okay, so for this question to begin with, you're gonna try to get the probability of each event and define them. So in this case, it says that so 1 in 1,000 people have a particular disease. So this give us information about a probability of a certain disease. So let's call it PD. That is equal to 0.0.001, and the test for the disease is 98 correct in testing for the disease. So that means the probability that a person with disease tested positive is 0.95. So if we define like positive, test for the 95% correct. So the disease positive, right? That's equal to 0.95. Okay, so on the other hand, the test has 1% error rate if the person being tested does not have the disease. That means when the person does not have disease and it's been tested positive, that is 0.01. I'm just using this to describe the counterpart of D, which means it doesn't have disease. This person does not have disease. So now we can use Bayesian theorem to solve this. So according to this, the information we got above, we got positive. Yes, so this is what we are trying to figure out, right? So to calculate this, the person tested positive and that person do have the disease. So equal to positive disease times P disease divide P positive. Okay, so this is according to the Bayesian theorem. And as you can see, we already have this here and this here, but we don't have this. But we can find out. How to figure out this is that we have this like this line. So we can find out the D times P D, right? And we have the opposite part, which is P positive times P. And through this, we know we know we got this. So how do we figure out this? We already have this, and this, and this. And from this, we know P is equal to 0, 0. Right? So now through this, we can figure out what's P positive. It equals to point times PT 0.001 plus 0.01 times 0.999. Okay. And yep, basically this will be equal to positive D. Just double check. It can be pretty much confusing for the eyes, so I recommend to double check. Okay, and here, right? Okay, so this is the final answer. Okay, let's move to the next question. All right, actually, not yet. I do want to sort of interpret the result. So the answer of this question would be 0.0892 approximately. And in this case, it's we are figuring out when a person who is test positive really like do they and the chance that they do have disease. So the interpretation of this question is that if somebody tests positive, the odds that they actually have the disease are approximately 8.92%, right? So this is not high at all for the false positive rate. Uh, so I just want to emphasize that the interpretation part, if we are interviewing a data scientist role, it might be asked if we are given the such probability question. All right, now let's for real move to the next question. So assume two coins, one fair, having one side heads and one side tails, and the other unfair, having both sides tails. You pick one at random, flip it 5 times, and observe that it comes up as tails all 5 times. What is the probability that you are flipping the unfair coin? Please take your time to solve this question if you prefer, and I will provide the solution later. Okay, dokie, let's move to the solution for this question. This question is a little tricky, but it's interesting at the same time. You think it's hard, but it's not. It's another Bayesian theorem question. So if we define A and B, A is the unfair coin, while the B is coin that shows tells 5 times straight. Okay, and then the question here is that what is the probability that you're flipping the unfair coin, and it all comes as a tell as all 5 times as a premise. So we in this case we are looking for probability of A given event B happens, right? So probability of the unfair coin, while the event coin that show tells 5 times straight, and we already know the formula for this based on the Bayesian theory. Let's write it again. PB. Okay, now let's try to figure out them one by one. What is B probability B given A? So this is the probability of coin that shows tell 5 times straight given A, the unfair coin. But according to the question, the unfair coin has both sides tell, so the probability of this happen is 1, right? And then we are looking for probability of A, which is the probability of unfair coin, which is 50%, because assuming 2 points, one fair and one not fair. So pick either one. You pick one at random, so it's half and half. And then probability of B, which is coin that show tells 5 times straight. And then in this case, you have condition one when you have the unfair coin, and condition two when you have the fair coin. So when you have a fair coin to tell show tells 5 times straight, that is this, right? And then if it's unfair, coin, then it's on the if you're choosing the unfair coin, then the probability is 1, right? In this case. So you are this because half time you're gonna get this, and half time you're gonna get 0. Okay, so this is answer. And so now we know what to write. So it's 1 times probability of A and divide probability of B, which is this. Okay, so the answer here, great, it just gave it to me 97%. Okay, so here's this is the answer for this question. Let's move to the next question. Players A and B are playing a game where they take turns flipping a biased coin. Another coin question. With P probability of landing on heads and winning, player A starts the game, and then the player passes the coin back and forth until one person flips heads and wins. What is the probability that A wins? Okay, please take your time and try to solve this problem by yourself. I'll come back later. All right, so for this question, we are starting from listing out the the cases when A wins. So the first time if A wins right away, then the probability of A winning is P. And then it's B to play. And then A can win on the third time. And this case, the probability of A winning when she wins on the third time of the game is A minus P. That's 1B has 1 twice, has failed twice times P. Right. And then following fifth time. A wins fifth time, and it's similarly a B must have failed 4 times. Times 1 time that A wins. So you can see there's a pattern, which is it's like a like 2n, right? Times P. So if we want to figure out the PA, then you want to add all this up. P plus this plus this more. That's right. And here is infinity. To add this one up. So if you observe, this formula is actually can be used as an infinite geometric series. So infinite geometric series is one sum equal to a divide 1 minus r. This formula depicts one sum is equal to a plus a times r plus a times r 2 times plus 3 times and till actually till r a times r n times. So this would equal to a, so okay, and then n start from 0. N starts from 0 to infinite. So here is the same, right? And starts. So if you see these two lines has a similarity, P here equal to A, or more like P here equal to A, and R is equal to 1 minus P, right? Squared. So in this case, we know the sum is equal to P divide 1 divide 1 divide P squared. This one equals to 1 plus 2P plus P squared. And then this would be P minus this. And then you get 1 P, right? And then you get this. So which is P divide 2T. Oh, oops, I did something wrong here. So this would be, this here, it's minor. So here, it should be this, right? And then you can divide P to P. So this would be the answer for this question. Okay, let's move to the next question. 3 friends in Seattle each told you it's raining, and each person has a 1/3 probability of flying. What is probability that Seattle is rainy, assuming that the likelihood of rain on any given day is 0.25? All right, this is a classic question. Take your time to answer this question. All right, this is another Bayesian theorem question. It's a bit similar to the question we encountered before, the disease question. So similarly, in this case, we are trying to find out one the three friends says that it's raining and it's really raining, right? So let's try to define the rainy, right? And friends say it's raining. Three friends say or say it's raining. So I'll mark it as T. So, and we want to figure out when it's really rainy, when it's really rainy, given the friends are saying three friends are saying it's raining. Yep. So according to the Bayesian theorem, this would be. Okay, so let's try to find out the PR. This is one. It's raining, and three of my friends told me it's actually raining. So, this is if it's raining, then my friends told me it's raining, then they are telling the truth. If they are there's 1/3 chance that they are lying, then 2/3 probability they are telling the truth, right? So it's 3 times 3. And then let's try to figure out PR. PR is probability of it's really raining. It's 0.02.25, right? And then PT, this is 3 friends both telling me it's rainy, but we don't, given it's rainy or it's rainy, it's not rainy. So so condition 1, rainy, say it is rainy. So a given day, a rainy day, it would be this, right? 0.25 times they are telling me the truth. So 3. So conditions is 1. It is not raining. It is raining. So, and it's 70%, 75% chance that it is not raining, and they are lying, right? They are all lying. Okay, so this is condition 1. Last condition. This tells you that's 3 friends will tell you it's raining. So which equal to great. It's telling me the answer. So the final answer for this is and 5. Can you tell me the answer? Nope. So This would be the final answer for um, P, the probability of raining when three of friends are telling me it's raining. Given three friends are telling me it's raining. So the answer is 0.7273, which is equal to 72%. All right, this is the answer for this question. All right, finally, we're moving to the final question. This is a very classic question, and usually it can occur in quant researcher interview as well. So this question is, you draw a circle and choose two chords at random. What is the probability that those chords will intersect? One thing to notice here is that you want the chords to stop in the circle. So the dots are not inside of the circle, but on the edge of the circle. So please take your time to solve this question. All right, so for this question, there are two type of solution without complicated calculation. The first solution is that if you just pick 4 dots at random on the circle like this, and assuming this like A, B, C, D, and here, as you can see, like if you choose A, B, then it wouldn't intersect. So does if you choose CD, right? If you choose like AC or BD, it doesn't really intersect as well. Only it's when you are choosing AD or BC when it's intersect. So this rule would apply to all these kind of four dots on the circle. So out of 6 dots on the circle, 2 of them will intersect. I would say like 2 lines on the circle, 6 lines on the circle, 2 of them will intersect. And this applies to all dots, all types of circumstances when you pick 4 dots on the circle at random. Right, so here it comes. Okay, so for the solution 2, this one is you start from pick A, B, C, 3 dots randomly on the circle. So A, B could be here, and AB could be here, and AB could be here, right? And then the C, well, A could, like ABC, you choose it randomly, either way. So let's interpret the intersect. If you want, if you draw a line of A to B, and then the final line of C to D must be within this range, right? A, B, and C, and D. So we need to calculate the probability when the D falls into this range between A and B. And we know that AB is really movable. AB can be here, can be here, and with all the possibilities with like also these A, B, C are interchangeable. as you can see, like the AC is, the range is here and BC is here. So AB would be 1/3 of the whole circle. So this method, to summarize, is to interpret the question this way. Find D on the circle, on the edge of the circle, making a line of AB and link CD that would intersect with AB. And then D has to fall in on the edge of the circle between A, B. And as we pick dots A, B, C, D at A, B, C at random, and line A, B at random, the probability changes, but it's the distribution is symmetrical. This means when you move A, B below or go up, if you make it go up or go below, it would be increase the probability of C or D, CD to intersect with AB, or decrease it. But since it's asymmetrical, we only need to consider when it's perfect triangle, right? So 1/3 should be the answer. I hope my explanation makes sense. Again, this is my first time trying to explain the mathematical questions in a video. And please let me know any feedbacks, whether my explanation on this question makes sense or not. And this will be the end of this video. Thanks so much for listening.